In this video, I'm going to show you how to use the emulation mode in ACR1252u. So I'm going to cover the following 6 points: the emulator versus simulator, the MeFair ultralight emulator, and where to find the documentation, and the MeFair ultralight memory structure, and show you how exactly the emulation works on the physical device and some of the technical stuff. So if you go to Google and type emulator and simulator, so probably the first paragraph you see here has got some nice wordings about these two words. So it says simulator is the environment which models, but an emulator is one that replicates the usage as a original device. This is exactly what ACR1252 is trying to do. So the ACR reader writer is trying to replicate a card. So it is going to behave as a card, not as a reader writer. So if you go to this ACS website and look at ACR1252 page, you can see that under the features section you can see this reader writer supports 3 modes. It's over here, and the first mode is like a normal reader writer. The second mode is a peer-to-peer mode, which is also present in the previous version of reader writers. The last one, which we are going to talk here, is about the card emulation mode. The documentation says ACR1252 emulates or can emulate 2 types of cards. One is the MeFair ultralight, and the next is the Felica. I just don't know. I've not seen this any Felica cards. So, but I'm going to show you how to use MeFair ultralight, because MeFair ultralight is one of the a popular card in transportation, I suppose. So if you already have this reader writer, probably you have to go and get a copy of the documentation. So in the same website, if you go to the downloads, you can see all the drivers, and what you need is the last one, the last document, the application program interface. The documentation is very good, and in fact, I was really surprised how easy ACR1252 has made to emulate a tag. So just grab a copy of the document. Probably you can download right from this page, or you might have got this documentation in a CD when you bought this device. So next I'm going to show you the memory structure of a MeFair ultralight tag. Now this is the documentation you can download from the NXP website, and this MeFair ultralight tag is one of the simplest and the easiest tag to understand. And as you can see here, it has got 16 pages with the 4 bytes in each page, and the first 3 pages has got the serial number and the log bytes, and the 4th page is the OTP, and the remaining pages are for the user data. So it's a very simple structure, and if I'm just going to show you the similar structure in the documentation from the 1252. Now this is what the documentation says. So what the documentation mentions is you cannot access the first 3 pages. You cannot directly read and write to the first 3 pages. but the remaining 54 bytes, or the remaining like page 3 to the last page, is available for you to read and write. So you have to keep in mind the this page, the page number 3, is called as a OTP. It's like in a one-time programmable bit, but you can also use that as a data, and most NFC tags use this page to record a default something called NDIF structure. So let's not go into details about that. So to put in simple words, the emulator mode allows you to read and write these 52 bytes. Okay, so I have the learning software up and running, and I have connected two reader writers to my PC now. The white one is the previous version, the ACR1252u, and the black one is uh, the latest one. It's 1252, which supports the emulation mode. So keep in mind, the 1252u doesn't support emulation mode, but both supports the peer-to-peer mode. So I'm going to click on the show readers, and before that, see, this feature is available in the version 1.5.5. So I'm going to show all the reader writers that are connected to my PC. As I mentioned in my previous videos, the 1252 has got two interfaces, one for the standard cards, and the other one is for as a SAM module, which which is inside the chassis. I mentioned this in my previous videos. Okay, so let's go and see the structure of a MIFARE ultralight tag. So I'm going to, this is a brand new ultralight tag, and this is like a paper based, not a plastic one, and I'm going to use the 122 and click on connect. And as you can see here, it's a very simple structure, and it has got the first 4 pages, or the first page and the second page has got the serial number, and every card has got a unique serial number, which is 7 bytes, and this serial number is present in the first 2 pages. The next page is the log bits. The documentation says as of this version, the emulator does not support the log bits. So I'm going to discuss some of the technical stuff after this hands-on. And the OTP is 0. This is a brand new tag, so the OTP is 0, and the remaining comes with some default values, and this is the content of MIFARE ultralight tag, a brand new tag, I would say. So I'm going to do the same thing this time, but using the 1252 and say connect. So there's no difference here. I'm just showing the same tag using both the readers. So now we know the structure of a MIFARE ultralight. Let's see how to use this emulator. So I'm going to start the software again, or you can just hit this show readers, and when you select 1252 pick 0, you're going to see this menu called emulators. I've called emulators, and I got only one submenu there called MIFARE ultralight. I'm hoping ACS will come with more emulators, for example for NTAG 213 or Classic and etc. Now there is a different way to connect to this device, and to keep in mind, I do not have any um, RFID tags on the reader. So we are going to directly communicate with the device. So when you click on the ultralight tag, so I'm going to move this on the left side so that you got enough space to see the video on the bottom right. The first thing we have to do is connect to the device. So some of these messages I'm showing here, it says connection OK, and in the commands tab you can see the various PCSC commands I have used. So when you say and read entire tag, so this is what you get from the device. Now this is the emulated copy of the MeFair Ultralight, and if you refer back to the documentation, you got 52 bytes here, and the byte address 0 to 3 corresponds to the OTP. Okay, the page 3 what you see here is actually the OTP, and the default value is E11008. This is how the NFC compatible tags are recognized. This is just some kind of a header. Now the documentation clearly mentions about changing the mode. So before we use this device as emulator, you have to set the mode to the emulator mode. So there is a command to do that. Click that. Somehow I get this error, so I'm going to first set it to normal mode, then go back to emulator mode. So from now on this device will behave as a MeFair Ultralight tag. So I'm going to disconnect and close. So I'm going to use this 1252 as a tag now. Because I'm working on two tags simultaneously, I have got a bit of an issue, something to do with probably the programming PCSA. So I'm just going to place the original ultralight tag and make a initial connection. That's fine. And now I'm going to use this. I'm going to place this above that and click on a connect. So look at that. So this 122 reader writer has recognized a MeFair Ultralight tag. So this is not the tag, this is the 1252 that is behaving or that's emulating a tag. And we have seen the 52 bytes from here we have seen, and see every MeFair tag must have a unique serial number, and this is the default serial number. See, the main purpose of emulating a tag is for us to change everything in the tag. So I'm going to show you how to change even the UID. Now this is pretty interesting here, and as you can see this software is trying to read everything from the tag or everything from this emulated tag. So you're getting content of page 0, page 1, page 2 and everything. So now we know that 1252u does work as a MeFair Ultralight tag. So you can, I'm going to make some changes here and see whether the changes is stored in the device. So just go to I'm just going to write ACS1252 is awesome. And I'm going to copy this text from page number 4 onwards. Save. And I'm going to transfer everything from page 4 to page 9. So this is like writing data to the tag. So I've done with that. I'm going to close. Next I'm going to take it out you have to remove this if you want to again access this device. So this time I'm going to connect um, to 1252 and go to emulator mode and connect and click on reader. So how cool is that? So as you can see here, whatever we wrote using 1252, we are able to read it through 1252. So I can see that we just wrote ACS1252 is awesome. And so let's try some of the other commands available in emulation mode. So we have got a command to set the UID of the tag, and also the command to write to the tag. Here I have shown writing entire tag. However, if you see the documentation, you can write data to a specific page or a specific byte address. So I'm going to write something at page number 10 or byte address 28 to 31. So I'm going to, this time I'm going to say, so ACR space is, say, awesome. Okay, so I have to give values for all the box, otherwise you get error. Okay, so here I'm not given a feature to write to a specific addresses. However, it is possible. I have just writing everything from address 0 to address 52. In other words, I'm writing 52 bytes when you hit this button. So write the tag. So the entire 52 bytes are returned. If you go, you can see what's happening. So I'm using this PCC commands. The entire 52 bytes are transferred, and I got a success message as well. So we have just returned something to the emulated MIFI tag. So I'm going to close, and this time I'm going to see whether this data is visible. Go to one. I'm going to use this as a tag now. Look at that. So whatever we wrote, so we just wrote ACR12, sorry, missed that 122. Okay, ACR122. Oh, this is awesome. Okay. So next is I'm going to show you how to change this UID. Again, there is a command. If you see the documentation, there is a command to change the UID of the tag. Oh, so sorry, you have to type the UID, and you have to keep in mind, if you look at any MIFARE documentation, the first byte always starts with 04. That is the manufacturer code Philips, I suppose, and there is some convention you have to follow when you give UID. So I'm going to just, because it's my emulated tag, I can give anything. I can just give A1, A2, A3, A4, A5, A6. So there is a command to set the UID. Somehow I could not see any command to read this UID. So the only way you know whether the UID has changed or not is to go back and read this 1252. You can use your mobile phone, or if you're working with Arduino or reader writers, you can read. So it doesn't matter. So if you, whenever you hit this entire data, you just get the data, you never get the UID. So we just wrote the set UID. I'm going to close. So I'm going to connect to 1252, and look at that. So the UID has changed as well. So we just change the UID to 04, A1, A2, A3, A4, A5, A6. You can also see this UID is present in these 8 bytes as well. So that is all I have to say about the emulation mode. I hope you understood what I have mentioned about emulation mode. um, I'm going to spend some time discussing the technical side of this emulation mode, probably what the documentation says, and how to do that in using PCSC commands.